Okay, so hope you enjoyed Galra's presentation. I would like now to invite Mr. Christoph Klein. He's a project manager of additive manufacturing in ThyssenKrupp, and ThyssenKrupp is one of our biggest sponsors. They helped us establish Metal Point, which is the Israeli Innovation Center for Metal 3D Printing here at Impact Labs facility. Together, we bring a lot of knowledge and a lot of opportunities and resources from abroad, from ThyssenKrupp and from other corporations worldwide, because we understand that the knowledge here of metal printing in Israel is limited, and we understand that we have to bring knowledge from outside, and ThyssenKrupp is one of the leading 3D printing corporations that implemented the technology in the world. And I will let Christoph share their view on additive manufacturing.
Okay, thank you. First of all, thank you for the invitation of the chance to speak here today. Unfortunately, I cannot use the camera or webcam on my computer here because, yeah, in the submarine business, things are a little bit more conservative, and we have a lot of security restrictions, and yeah, but we can manage like this, I hope. Can you see the screen? Okay.
Yes.
So I would like to tell you a little bit about what we are doing in the defense business and the shipbuilding business. What you see here are the two examples of our products. First of all, submarines, of course, and of course surface vessels. And we're doing a little bit more on the submarine business with additive manufacturing because the space and weight requirements and the technological complexity is much higher in the submarines compared to the surface vessels. So first of all, I would like to tell you something about what we're doing in general, then the application areas we see for additive manufacturing and the short outlook on the topic. So we have we see us here a little bit in the center of different activities. We have close contacts with the tech center additive manufacturing, and there is a little bit of a change has come up in the last weeks or even last month, because this tech center that was established by the ThyssenKrupp Corporation for the whole corporation was taken over by us as a shipyard, and now it will be transferred to Kiel, and we will have a complete center of metal and plastic printing then on the shipyard. But together with the colleagues from the Tech Center and the DNVGL as a certification authority, we have managed to get this certification for the production side and for the material. I will come to that point later. Then, we're also in close contact with universities and research facilities like the Fraunhofer IRPT in Hamburg, and also the university in Aachen, which are more or less front runners on the topic. Also, as mentioned in Gal's presentation, as far as I could understand, my Hebrew is a little bit rusty. We are in contact with the Deutsche Bahn and the network, the Mobility Goes Additive, and we're trying to learn from experiences they made in promoting additive manufacturing. And also with the colleagues from Airbus and from Bombardier and also Danfoss, where we try to learn from their experiences. We try to hand over what we have learned in the past, and it's always good to have discussions with other companies, not only from your own business, because they have completely different experiences and also different applications, and it really helps to get in touch with others. Then fourth pillar here also is the supplier side, because a big part of our production is provided by suppliers. So I think we have around 30% of the parts we install on the submarine is produced by us on the shipyard, and all the rest is provided by suppliers. And so this is a very big lever we have to work on, to get in touch with our suppliers, to promote additive manufacturing there as well, and to see to it that they can also produce AM parts in the quality we need them, and to get that installed on the submarine. So that's a big topic we are working on currently, and that will be increasing. There will be increasing work in the next month as well. Then, activities of the last months and weeks. We have set up, you can see that here on the upper side, we have set up an internal wiki on the intranet, where we inform all colleagues about design guidelines and tips about additive manufacturing, also showing them the parts we did as examples, to really promote the topic and let them see what can be done by this technology. And we had training courses by our colleagues from the old Mülheim Tech Center. They did training courses for a lot of colleagues in the company. We did training courses for the management level, and also for I don't know how many, it was around 60 to 100 people in the design departments, to tell them at least as a start the basic knowledge on additive manufacturing, so that they can check in how far that's applicable for their departments. Then on the left side here, this is the flyer from the last action we did, where we're in the last steps now. We started a big innovation or idea challenge, where every employee in the company could take part and hand in his or her ideas on additive manufacturing. And this was a very, very good experience. We also, for that topic, were in touch quite closely with the Deutsche Bahn. And in the end now, we had around 54 ideas, which we're now evaluating. And I have to say, all those ideas were very good ones. There were hardly any ideas that cannot be used for any future work. So that was very good result. And that's also a topic I can promote if you really want to get ideas. We've checked, and also we're in discussions with other companies to get ideas in corporations. The software solutions we saw until today were not that helpful. You can get a lot of data out of SAP or other ERP systems. There are also technologies where you can use your CAD data. We're also checking software there. The ones we saw up to now didn't really work. The results that came out were not really helpful. But asking the colleagues, asking the employees to hand in ideas to certain problems is a very good way of getting ideas which parts could be printed. So that's what you can see here is the certification by the DNVGL, and we certified the submarine steel we use for the German submarines, which is an amagnetic steel. And the good thing now we have is that we can print certified parts. And so with this, we are the first in the maritime business. We don't have to do 100% test now on every part we're printing. We did the certification of the production site and the production method on the machines. And now the parts that are printed there can be certified after printing, and they don't have to be checked. Not every part has to be checked 100% in a test lab afterwards. We have a material scientist there working for us, and what you can see here, the results that came out is that the printed parts, this is here on the right part of the table, the printed parts has better mechanical properties than normal conventional material. So that surprised us a little bit, but in the end, of course, you have very, very defined environmental conditions in the printing machine, which helps you to be able to really control what is happening in the machine. And so there would still be more chance for reduction of weight and size in parts when you really take these values into consideration. So on the next slide, I can show you a small movie we shot here on our own to promote the topic. I hope everything will work. So you can see some things of our shipyard and about what we have done here. That was done for our subcon convention.
We all like to build things. And we do it from childhood onward. We might only have a bucket of sand and some sand molds, but there are no limits to our talent. And of course, no molds for that. We build as well, and we build without molds. We build in plastic, metal, or even ceramic, using various methods in individualized design. Steered by us and made available in digital form worldwide, right up to completion at the customer's facility. Most of the machines process powder-like base materials that are built up in thin layers in a 3D printer-built chamber. Laser melts the metal or sinters the plastic in the precise position where the component is to be built. The outcome, far less volume and weight plus optimized functionality and significantly shorter delivery time. Topologically optimized parts, Mother Nature shows us the way. Bionic structures, the possibilities are almost unlimited. Material is only used where it is actually needed, from prototypes to serious production. The digital value chain from the 3D model to the final solution on board a vessel anywhere in the world. We don't print entire submarines, but on board you'll already find parts that fulfill all the requirements their deployment demands, even with the Germanischer Lloyd certification. Our aspiration is to be Europe's most modern naval company. We develop the naval standard for tomorrow's world. We are ThyssenKrupp Marine Systems.
Yeah, so we used this short movie to do some promotion also with on the customer side, but also a lot for internal promotion. And that's really a very, very important thing to get into people's minds, that they see this new technology, they see what is possible, and to be present all the time so that people contact you when they have a problem, where they need a solution to. And that's what leads to the next topic. You need parts to present and parts to print. And like these always cited lighthouse cases, you need some parts where you can prove that the technology is working and that you can solve people's problems. And we started off with a quest to save money by printing, which can be done. We can do that. We did that with our hydraulic block you saw in the video before. But the main topic, I would say, is not really saving money. It's possible, but since the technology is quite expensive, you really have to see where it's possible to save money. But in general, you can do a lot more. you can save a lot of time also, and time is money more or less. But here with the part, you can see it's part of a cooling circuit. We were approached, I think, 1 week before Christmas by colleagues and asked if it's possible to get a part in 4 weeks. And yeah, over Christmas and New Year's Eve, the whole company is closed and not much is happening here at all. But we were able to redesign the part, and this is the lower, the upper end here, the structure. The rest is conventionally manufactured, but here this part is additively manufactured, and we were able to do that in these 4 weeks, and by that we were able to reach a milestone, and yeah, that was a very good topic, showing that it helps you to save a lot of time. Then the next topic, here we were using wire arc additive manufacturing. This is for prototypes of a battery system, and it's also produced in this 3964 magnetic steel, which is really hard to machine. And yeah, we built up this structure here layer by layer, and only had to do the final machining, and that saved in this case also a lot of costs compared to conventional machining. And right now, for all the prototypes we're using of the battery system, the parts, these housings are made like that. For serious production, when you look at cost, additive manufacturing is not really the technology of choice, but for prototyping, this really helps. Also for prototyping or for testing in the submarine, what we do is we use our FDM printers and build up parts, for example, like this housing, so that we can go onto the submarine and do the installation checks when you have to measure piping and cables, and you don't have the original part available because it's not delivered yet. It really helps to have the possibility of printing some of your mock-ups, so that you can measure your parts and continue the design and installation work. And also with SLS, we've have gained some experience. We're producing parts, and the plan is to have more parts on the submarine. For example, like cable holders, we are currently machining, and there are possibilities of using SLS printing there to make it simpler. Yeah, the application areas. On the one hand, it's the normal shipbuilding, let's say, building of new ships and submarines, and also the service business, which is also a very important area for us. So yeah, I don't have to talk much about printing in general, but what can be printed? It doesn't make sense to print everything. If you have a hydraulic board like that, of course you can put it into a printer, but it doesn't really make sense. So we had some ideas here. We were started off with printing some prototypes, and then the colleague who designed this part went through several iterations, and you can see here the weight. We started off with around 13 kilograms. Then he had a part with around 1.7 kilograms. He also made the experience that you have to really consider how it's printed. So I think in the end, at first he started building it in an upright position, so he had to print a lot of layers, making the part quite expensive. And in the end, he came up with another part, which is a completely different design. In the end, it's still fit for function. All the connections are on the same locations, but the part itself looks different, and it weighs less. And we had this next step for this part. We didn't make that yet because at the moment we were still stuck with the current installation and connection dimensions. But if you completely redo that and go away from the conventional one, you have the chance to even save more weight and space, and yeah, do some other design changes. What we have not yet tested is in how far we also save or reduce acoustic performance of the hydraulic block itself. But that's also something that's checked now. So nothing happens here, no? So, okay, and then the service business, it's a little bit different. We cannot start completely with new parts, and what we are planning for the next project is really to integrate additive manufacturing in the design phase. So we want to have additively manufactured parts as a normal production method on the next projects. So because when you look at these conventionally designed and manufactured ones, it doesn't really help, or you have to do some extra re-engineering, which makes it quite costly. And in the end, you have to check in how far it helps you. In the service business, of course, quite often the delivery time is an issue, because if you can print something anywhere in the world, for example, on demand, you don't have to put all the spare parts in stock. You could just print it, I don't know, when you're on a mission somewhere on the submarine or on the surface vessel, anywhere you are in the world. That could be of help, so that you don't have to buy all the spare parts in advance, or you don't have to stock them on a ship, and that's an objective we were thinking about. Also, for parts that have become obsolete, we always have that problem. When a submarine is produced, it takes 6 to 7 years. Then it's operating for at least 30 years. And really having all the spare parts available for that long period is often a problem. And, printing could be of a lot of help there. Yeah, quick reaction times, I had that before. Even if printing the part like that hydraulic block we saw before, it takes, I think it was 24 hours on the machine. It sounds quite long, but in the end, it's really fast, even if you have to add some machining. If you have that part available in 1 week or so, it's a lot quicker than having some part casted or milled, whatever, and it gives you a lot of chances for the service business as well. So, and is it as simple as just printing by pressing a button on the keyboard? So, of course, not really at the moment. There are some issues that have to be addressed, like, for example, the intellectual property rights. What I said before is that around 70% of our products installed on the submarines come from suppliers, which, of course, results in a lot of spare parts coming from suppliers. And, of course, we don't have all the IPR and the data to be able to print that. So there would have to be a lot of newly designed contracts, new discussions on how to handle all this IPR topic, which would be an idea to have more licensing models where you don't buy parts anymore, but you buy a license to print parts. And of course, at the moment, that's not possible for all parts. When you buy a radar system, you won't print the radar system, but you might be able to print parts out of it. But we're working on that as well. Then the warranty topic is also something that is not so easily clarified at the moment, because in the legal way, who is the producer of a part in the end when you print it? If we send out a file to a customer and he prints his part, and then there's a problem. But is the manufacturer the one who prints it, or the manufacturer the one who designs the part? And there's still no real clarification on the legal side, but it's also something that will be done in the next month or years, I think. And of course, production knowledge, just simply sending out the CAD file or the printing file does not really fit, and is not really everything you need to be able to print a part. So you need some more knowledge on machine parameters and all that stuff. yeah, another vision we are having now is that we would like to have a like a platform which is currently done by, or was done by the ThyssenKrupp Corporation together with IBM, called International Data Space, and there would be a connection between, for example, us and printing hubs in the world that is secured by blockchain technology, and so you're able to see in how far your data transfer was corrupted, so that in the end you know the correct file is printed, and also some licensing models shall be clarified by that technology. But we're testing that, and that will be something we will use in the future. So our outlook is printing is a good thing. It's not suitable for every problem, but you can do a lot of things. Printing a complete ship still is science fiction, but yeah, on a lot of ends, the size limitations are worked on, and so I think we will. It will not take that long to be able to see big parts being printed, or bigger parts being printed. The cost issue still has to be addressed in order to make it more attractive to use printing compared to conventional methods. So our vision is that we would be able to print bigger parts, especially in shipbuilding. We come to big parts quite easily at lower costs, and we would like to have additive manufacturing as the future standard. And this is still a little bit more science fiction to have printers on board. For plastic printing, that's already working, but I would like to see really metal printing on board, but it only helps when you have all the data available. There are a lot of things to clarify, but it would be really cool to have a metal printer on board, and you're able to print really usable parts on your ship. Yeah, in some areas at the moment there's still more questions than answers, but we're working on that, and we would like to go into a close cooperation with the customers on the one side and the suppliers on the other side. And yeah, if anybody has ideas, questions, whatever, feel free to bring it up. You can also see my contact details, and that brings me to an end. Thank you for your attention, and if any questions, just tell me so.